So to navigate the file system, if you use a command called tree, which is not always installed, but if you do that, it will show how your directory structure looks and which files are there. And I am showing it here on Tetralit where it is installed. I'm just going to go into my idea and create a file or two. And then I'll do tree again. And you can now see that you have the directory you created first. There's a directory under it, and there are also files here. So tree is a good way of seeing the structure of your files and directories. Of course, if there is a lot of files, a lot of directories, then it becomes fairly useless. As I can show you here, if you go to the top level, I believe you're there now. Yes, you can see here some of the common directories. I will do tree, and you can see there are just enormously many files. So that's not so useful. And now I'm back again. And doing tree here only shows the directories below this directory you are in. There are some common ones. And I can see if I can open this here. So maybe make it a little bit larger. So some you will almost always see on a Linux system is bin for binary files, executables. And the home is where most of the user directories will be located. Then you have some library directories. And sbin is also some binary files. And temporary files will go into temp and things like this. So these are these are the common directory structure of a Linux system. And I have also written it out here, what you have in the various directories. And as you can see here, home is where you will find your home directory. So, and I also note here, as you just saw, if you are on an HPC center and then you of course have to go to the top level to see these files in this structure. Otherwise, you'll just see the files in your own directory, but there will probably be quite a lot of files, as you just saw. Okay, the ls command that you just tried is for listing files and directories. And if you just give the command ls with no flags, and flags are these things here that you use to tell it to change the output in specific ways. Then with no flags, it will list all files in the current directory with the exception of hidden files. And hidden files in Linux are those that has a dot in the to begin with, and that is usually configuration files. So there will be a let's see if I can go to the, if I do ls minus la or just minus a, then you see also the hidden files or the dot files, which are the configuration files. And you can see here, they are here. And on a bash shell, this is actually the main configuration file. And this is the one that you make changes to yourself, usually on this system here. But you can see here, these are some of the files that are in my directory, and there are some. If you have been logging in with ThinLink, it will have created these top-level directories. Things like desktop will not be there until you have actually logged in with ThinLink. But these hidden files, the configuration files, they will be there. So some of these examples here are, if you just do ls and then the slash, then it lists the content of the root directory, like that. You can see that is what you also saw if you go all the way out here. The root directory, it looks like the same. And if you want to see the content of the parent directory of the current one, I'll just show. If you type cd, you always go back to your home directory. So if there will be a level above it, as you can see, that's all the user directories. So that was this command, ls 2 dots. If you do ls and this symbol that is called a tilde, it shows the directory of your home directory, the content of your home directory. So you can see, since we're in the home directory, it looks exactly the same, doing ls and ls tilde. But if I were in public, then I have no files there. But if I then do ls tilde, I see what's in my home directory. And ls a star will list the contents of the current directory as well as all the subdirectories. And you can see there was quite some files there. And you can see here there are some commonly used flags. Ones you will often use is this one -a, because it also lists the hidden files and directories. And the -l will list in long format, like this. And that lists permissions, owners, size in bytes, modification time, and also the name of it. And I will talk a little bit about permissions in a short while. And if you do the same but put an H there, then you also get the size of each file or directory. And R lists them sorted by the last modified date. So if I add the R here, now they are sorted. So you can see the newest files are furthest down. And if it's instead -s, it sorts by size. So there is a lot of different ways to sort, and it's quite useful. So let's see how it looks here. So I have some examples here, the output of some of the flags for a directory that has 2 subdirectories and some files. And what I want to do is I want to go here, because I believe I put it here, didn't I? Yes, I have one here that's called temp tar set. I think that is the one that contains some of these files. So you could get that one and this one. And the easiest way to get all of this is to do a git clone of the whole directory. To do that, take this code here, and under HTTPS, copy this here, or you can also copy it by clicking here. Then you copy it. Then I will go to my project directory. Like that. I will do git clone, and then I will paste this here I just copied. Like that. And then I can go into the directory that I got from cloning. It's called intro-linux. I do ls, I go into docs, ls. Here is this file here, and I'm going to check if that was where it was located. I will go through this in a moment. Yes. You can use this to create a number of temporary files by unpacking that. Then you have something to play with. Otherwise, an easy way is to simply create them. But let's imagine we have a directory called my test year, and that has 2 test directories under it. Then you can use ls-a to see how it looks. I'm going to just use this to show you instead. You see, I have one here. It actually has a number of files, and it also has 2 test directories. And if I do my ls-a instead, then it also shows the hidden files. And in this case, there are no hidden files, but it will show you the dot for another word for this directory, and the dot, which is the directory above you. Let's do ls-l. And now you see the full format here, the long format, I mean. And here are the permissions we'll talk about in a moment. Here is which user owns the files, and which group of users owns them. And in this case, it's the group Intro Linux, which is the storage group for this project here. So everyone who is part of this project also are in this group and can access these files. And then you have the size. And you can see these are very small because I created them with touch. So there's nothing in them except for this one, which I put something into. There are also 2 directories. You also see when they were created, which I'm not sure is the correct date, but whatever. So let's do ls-la. In this case, the only hidden files are the ones for the directories again. It shows those as well. And then let's see that. Here, now it has the size shown as shortened form, and also here how many files there are in each. So that's practical. One I'm using a lot is this one, where it also sorts it, as you can see, where the newest is lowest. And let's again try ls* and see what happens, because then it also shows what is in the below directories. And you can see there's actually a directory below this directory. So let me go into this directory here. And then again do -l, and you see there's this one other directory here. I will just create a file. And then again do ls-l. Note that when you're on a Linux system, you can almost always use the up arrow to scroll through your recent commands. And that is quite useful so you don't have to write the same thing again. But this is how it looks here. So let's do ls-ls. And you can again see how it looks here. And there's only one file it tells you, and there's the directory. And as you saw here, this here, that is the permissions, and you can use that to easily see what the permissions are. And the D, that shows that it's a directory. If there's no D there, if that's just this arrow here, sorry, not an arrow, if there's just a minus, then it's a file. If there's a D, it's a directory. And the R means it's readable. The W means it is writable. And if there's an X, it's also executable. So you can see the stuff that are in these directories are readable, writable, and executable. And there are also 3 groups. The first group here shows the permissions for the user. And the second group of permissions shows for the group, which in this case is this Intro Linux project group. And the last group shows the permissions for everyone else on the system. And these can, of course, be changed. But as it is now, everyone on the system is actually, on this computer here, is actually allowed to read this file. So it's important to check which permissions are set. If you have something that you want to execute, you want to be sure there is an X set so that you can actually execute it if it's a binary or something. And you may also want to make sure that the people in your group can read stuff in your directory. So you don't have to always, for instance, put all the data files in everyone's directory. Maybe you just put it in one of them and make sure the others can read it. That could be one way. Of course, you may also want to make sure no one else can read it if you're writing something that you don't want anyone else to see yet. So, and here is a large representation of this, what it shows here. Another thing is, aside from a minus or a D, you can also have an L, and that means it's a link or a symbolic link. And I could do that by just, let's see, I'm in this directory. I'm going to go up 1, and then I will create a symbolic link with ln minus s, and I will call it subdir, just to call it something. And then I will go to dir 1 and dir 3. And now if I do ls here, you can see did not create a file because I did like this. Okay, so you should tell it the link you're going to make first and what it's called afterwards. So what this does is that it creates a symbolic link to a location. For instance, if you want to very easily go to this lower subdirectory from the top directory, you could create a symbolic link to it. And then if you do the ls minus L, it will show you it here. And then you can also see here that now there's an L showing it's a link. And one thing that is very useful is if you're on one of the supercomputers in one of the centers here in Sweden, then, or elsewhere, of course, then from your home directory, you could make a symbolic link to your project directory. And in that case, let's see here. Yes, project directory is this one. It looks like that. And that means that each time you are logged in to the system, you would have to type this line here to go to your project directory. But you could instead make this symbolic link, so ln minus s to your directory here, and then Brydsö, for instance. And it now creates Brydsö. And you can see I already had created one I called myproy. It's simply now 2 links to the same place. But that is a very useful thing, because then instead of typing the whole path, I could just write Brydsö like this, and I am now in my project directory. And here are some examples on what you do to change permissions. So in the owner directory, the owner group here, this is the first one, the owner group, the group, and the everyone else group. And if you say chmod, that is change mod, that is changing these permissions, then you could say plus rwx on a file that gives all permissions to this file or directory for yourself. And minus rwx would remove it instead. And if you just said plus x, you just add executable permissions, or you can just remove specific ones. The same for the group, but you add a G in front of it. And for everyone else, you add an O. And then you make the changes to these groups here. So you may also need to change who owns a file. And you would do that with change owner, chown. And that is much the same, but you use it to change who owns a file. So you say, for instance, that now I should own your file, then you would say chown my username and the file. The same on a directory. And there are instances where you might want to do that. For instance, you could want to make sure that a specific group has ownership of a directory, so you can share everything in that directory with your group. And you should note it will not make any output when there is success. So it will just do it, and you can then list the file and see that something has happened. So let's talk briefly about creating and removing directories and files. As you have already seen, I have used mkdir and the name of the directory to create a directory. To remove a directory, you would say rm for remove minus rf, which would mean that the R is recursive and the F is do it without asking. If you don't put the F, it will ask you, do you actually want to do it? And maybe that is a good thing to do if you're not sure, but it will ask for every subdirectory and file. So if you are very sure that you want to remove a directory, then just put the F there also. So this then removes the directory. And CD means to go to your home directory if you don't say anything else. And the home directory is also called $home. That's an environment variable, and I will mention that briefly later. CD dir, where dir is some directory, will change to that directory. It can only change to a subdirectory that's immediately below it. Otherwise, you need to give the full path. So if you have directory 1 is a subdirectory to directory 2, then you would have to say cd directory 2 slash or directory 1 to go all the way there immediately. Otherwise, you can change to them one at a time. CD and 2 dots, and note the space in between. That is change directory to the parent directory of the current directory. And as you saw before, touch some file will create an empty file with the name file. And this rm can also be used to remove files, not just directories. The command pwd will also be very useful. It will tell you the current directory path. So let's try create some directories, change some directories, remove some directories. And I will just stay where I am here. And I will suggest that you code along. So do that. So I will try to type not too fast. So I will say my test dir, mcdir, my test dir, like that. Then I will change to it. cd my test dir. I will then again create another test directory, test dir 1. And I will suggest that you now try the type push the arrow up, because then you get what you had before, and then you can just change the last letter to 2, and then do it again and get 3. I will just try do ls and see I have my 3 directories. I will try removing one of the directories. And you can see here I add the -rf. I can just briefly try to just say remove testdir3, and it cannot. It will complain. It says it's a directory. So I will put -r, and then it will remove it. And it seems that on Tetralit there is no need to use F for force, because it seems to be default. And you can see it's now gone. So let me go into testdir1 and create some files with touch. I will do file1 text. I will create a file2 that is a shell script. Create a file3 that I imagine to be a C file. So now I have 5 files. I will also do an ls and see that I actually have them. I will try removing it. This one here. I will do an ls. I will do a cd and space and 2 dots to go up 1 directory. I now am in my testdir. You can also see it changes here. It shows you the most recent, the current directory you are in. So let me try go into testdir2. And there is nothing in that, but I'm now there. And you can also do pwd, and it will now show you the path to where you are located. So, okay. So I'm going to assume people tried this if they wanted to. And this was done on Tetralit. Again, I mentioned this here, that it's only the current dir that is shown, as you just saw. On many other centers like HPC2N, also on most of your own Linux machines, it will show the full path. So like this. Yeah. Okay, you now know how to create and remove directories and files. But what then if you want to copy it? Well, in order to copy a file or directory, you use the command cp for copy. And you then say cp and then the file that you want to copy to a directory. And that copies the file into the directory. If you say cp directory 1 and directory 2, that copies directory 1 into directory 2. And you should note that it overwrites existing files with the same name. And you can also copy recursively if you add the flag -R. That also copies all subdirectories and files in directory 1 into directory 2. So in order to rename, you use the command mv for move. So you can move file1.txt to file2.txt. That means you rename file1.txt to file2.txt. You can do the same thing with directories. And you can also use it to move it into a directory. So move, when you rename with it, it complains if there's already a file or directory with the new name, but you can force the renaming with -f. That means the file or directory that was there before and had that name will now disappear. But it's possible. So I suggest to do an exercise. Try create 3 files with touch. Create a directory and then a subdirectory of that directory. And you could use the commands mkdir and cd to do these things. Create a file in the subdirectory, again with touch. Create another file inside the directory, move it to the subdirectory. And rename one of the directories. And delete or remove a file, or delete and remove a subdirectory. So try do some or all of these exercises just to test them out and see how it goes. And let's spend maybe 5 minutes on that. Or maybe let's see how it goes. Let's start with 5 minutes. And if you have already done it, you can take a 5-minute break instead. Let's continue. So I mentioned previously symbolic links. And symbolic links are also called soft links or just symlinks if you're Googling for it. And that is a pointer to another file or directory. And as I showed you, it's very useful both for ease and to make sure that you actually get to the right directory, and to avoid changing hard links if you're within some script or program. And that can be very useful. For instance, it might be that you're installing something that assumes a library is called something specific. For instance, libcoolness.a and not libcoolness.2.0.a. That is quite common, that libraries will have some slightly different name than what you need it for in your script. For instance, if it's a newer version or something. And then you can just create a symlink and make that point to the directory instead of renaming the directory, the library, or updating it. Because it might be that it mentioned many times in the program that you are installing. So it can be very useful to use symlinks. And as I said before, also for ease. So you can, for instance, make one to your project storage from your home directory or elsewhere. And I already did this example here. So I'm not going to do it again because we are a little pressed for time. So let's look at redirection instead. Standard input comes from the keyboard usually, and standard output will go to the screen. And there's also something called standard error, which is usually error that you get from your programs running that will also be thrown to screen usually. It can though be thrown to a file instead. And you can use redirects to output to send the output of some command to, for instance, a file instead. So if you want the output of ls to go to a file, you would do ls and then this arrow here pointing right to test.dat. And if you wanted to go to a file called this. If you want to concatenate the output of some command to the content of a file, for instance, add the output of ls to an already existing file, this file here, test.dat, you could concatenate it with what was already there if you do a double arrow. And the arrow to the left instead changes the standard input. And if you have this here, a 2 and a right arrow, then it redirects the standard error instead of the standard output. So maybe your program, when you run that, it throws some errors, or you assume it will. Then you can say that you want these errors thrown into your file error.log. Maybe your program already does this, but if not, then you can do it like this. And commonly, if you want to throw everything to the same file, you use 2 and the right arrow as here, and then for also 1, which 1 is the standard input. It's a common to use it for that. And that will redirect both the standard output and the standard error. And you would do that by saying, I'm running my program. I am redirecting the output to a log file, and I want both the standard errors and the standard output to go there. So that is one way of doing that. And there are some examples here that you can try and code along to. And I will go up 1. And if you created some of these directories, then you have, for instance, a file here. And let's do cat on it. Cat actually just puts the content of the file to the output. So I say cat file.txt. And I must have named it differently. I named it my file. And it contains nothing. So in this case, I'm going to add something to the file just in order to be able to show you how this works. So I will talk about editors very briefly in a moment, but I will just add something here. Okay, so let's now show the output of the file. It has the content. This is my content. So I want to throw this to another file. And I will first just throw it to file 1 text. And I will show that file 1.txt now contains the same thing. And let's assume I want to send the output there again. And I want to concatenate it to what was already there. And you can see now it's there 2 times. And you can also put some text. And to do that, if you use the command echo, it will echo whatever you write. I write something. So you can use that also to get stuff into a file. That is another way of putting content to a file also. If you don't want to open it in the editor and you just want something into it. So you can use echo to do that. So I will concatenate it to what is already in file 1.txt. And then I will show you what is in file 1.txt. You will see now this line is also there. And if you do it like this here, you can put an extra new line with /n. And actually that didn't work because I was supposed to use these. Okay, that doesn't work for some reason. I will look into it. But in any case, you can use echo to throw stuff to the file. And I will continue. And you can also add longer blocks of text to a file using the command line. And you do that by opening the file for writing with this command here. So let's take cat and throw stuff to foo. And then I will write something here. This is a test. Hello. Hello. And then to save the changes, you use Control D, and you do that by holding down Control and pressing D at the same time. And you can see it now contains this text here. So these are ways to put text or other things into files. For instance, you can also use it in your programs, of course. So let's look at pipes. And I will only do that very briefly because we have some more material to cover that I think is probably more important right now. But pipes are used when you want to take output of one command and use it as input to another command. And for instance, you could use this command here, that grep is used to look for something. And if in this case you are looking for the word string, and so here you will look for the word string, and then pipe the output of that into this command, and this command wc is counting lines. So you simply count the number here, so it will output the number of it will output string lines where string is in this file, and then this will count it, and then you will see how many instances there are of them from this command. And if you just instead wanted to find the instances of string in the file, you could instead output that to file.out. And it will actually take the whole line. So if you have a line that is, I have a string in this file. If you have that line in the file, then file.out will contain that whole line. And you can, of course, also append the lines to this file.out or other file. So another important thing to talk about is exporting variables. And environment variables have data that you can use in your program, for instance. And note that environment variables usually are by uppercase. And in Bash, you usually have a $sign in front of it. So there is some very common ones here, which is $home. That is another name for your home directory. It's an environmental variable that will point to your home directory. So we could, for instance, try and say echo $home, and then it tells me the content of this environment variable. And for me, that is this, my home directory on Tetralit. Then there is $pwd, that is the same as the command pwd. It contains the path to the current directory. So you could do echo $pwd, or in this case also just pwd. You can see it's the same. Then there is the $ld_library_path. That will be a colon separated list of directories that you use for your libraries. So that is the library path that you maybe set to make sure that your programs will find the right libraries. And you add to that by putting a colon and then the new directory there also. You can set the number of OpenMP threads with OMP num threads, or you can set the Python path, for instance. So those are some examples of common environmental variables. And to see the content of a variable, as I just showed you, you echo the environment variable. And you can use env to get a list of all environment variables that are currently set. And if you scroll up here, you see them. So there's quite a lot of them. And there are some environment variables that you need to export in order to use them. And that could be if you have, for instance, installed a program or something, and it has some variables that you need to set in order to tell the system that you are running that, or that you're doing something with that. And in that case, you export it. And an example of that is also the OpenMP threads. In order to change that from what it is, you do an export of OMP num threads equals whatever number you want. So I could show you here. Let's see what it contains. It probably is a 1 as default. It didn't have any value at all. And then echo is now 4. And we can change it to 8 and echo it again. And it's now 8. And you can also use this to add a path, for instance, to your library path. And it's important to note the environment variables only retain the value you have set for the duration of the session. If you open a new terminal window or go do something else, then you have to set it again. And to avoid that, you can set it in this configuration file .bashrc that is in your home directory. But you should only do that if you're sure you want it to be persistent across sessions. For instance, a library path might be one of those things if you have installed something. And it's possible to quickly add a new directory to your library path in this way with echo.